My name is Prashant Bondada, and I'm a database engineer on the RDS commercial engine team focusing on SQL Server. This is a breakout session, so I'll try to take all of the questions towards the end, and in case we run out of time, I'll be available outside to take any other questions that you might have. For this session, I thought it will be interesting to take a look into all the new features and enhancements that we made to the service over the last year, and I've divided it up into different domains so it's more organized and structured. We had a few breakout sessions at reInvent this year, and I do see a few faces that attended some of those, so some of this might be a repeat for you, but we do have a lot of new content also. Let's get started. A quick refresher about what RDS is for those of you who are not familiar with RDS. RDS is a managed relational database service in AWS. It's one of the oldest services that we have. We recently celebrated our 10-year anniversary. RDS makes it easy to scale, operate, and set up a relational database in the cloud on a platform that is secure and performant. As you can see, we have 6 relational engines for you to choose from in RDS. We have our own Amazon Aurora, which has 2 flavors, a Postgres compliant variant and a MySQL compliant variant. We have open source engines, MySQL, MariaDB, and Postgres, and we have the commercial engines, Oracle and SQL Server. A lot of work goes into provisioning a database, starting from scouting for data center locations, to provisioning infrastructure for network and power, to stacking up the servers in the racks, the hypervisor installation, the operating system, and the database software. All of this is taken care for you in RDS. When you have any software, you also have to think about patching. We patch the guest operating system. The database patching can be done by yourselves because we offer new versions of the database that you can upgrade to. If there was, say, a severe security vulnerability that might impact your databases, we will automatically patch that database instance. Backups are completely automated in RDS. We do a daily full backup, and we do transaction log backups every 5 minutes. We do all the heavy lifting that makes it extremely easy to do a full database restore or to restore an instance to a given point in time in RDS. We offer high availability, and when I say high availability, I mean the database can be set up to sustain the loss of an availability zone. Availability zones and regions. So let's just understand quickly what those are. So region is a geographically different location. Like Oregon is one region, Virginia would be a different region. Each region itself has multiple availability zones. Availability zones are physically isolated locations in a region. Now the reason a database in RDS can be set up to sustain an availability zone loss is because availability zones themselves have been architected to not have a single point of failures. So when you enable the high availability option, that's why we call that a multi-AZ option in RDS, because your database essentially is across 2 AZs. We, of course, monitor your databases and take recovery actions as appropriate. If you do have the multi-AZ option, we have additional monitoring to make sure that we are keeping the primary and the secondary in sync and ensuring that a failover cannot happen if something were to happen to the primary instance. Given that RDS does all of this, as a SQL Server DBA or a system user or a system owner, what is it that is in your responsibility? Apart from the schema design, the performance tuning, the user administration, access management, all those things, there are also quite a few configurations that you need to configure in RDS. Now, we set up and operate the instance basing on those configurations. So it's really important to understand what these configurations are and how you can configure those to make sure your database meets your business requirements. Now, starting with hardware, we have 4 instance families in RDS, and we have 2 storage types. We'll talk about that in just a bit. From the SQL Server database version and edition perspective, we support SQL Server 2012 to 2017, and we have Express, Web, Standard, and Enterprise editions. The Web edition is really interesting. It is not available to use on premises. It's only licensed to cloud vendors. It is not as restrictive as the free Express edition, but it's much cheaper than the standard and enterprise edition. So we have a few customers who are able to leverage this and save costs on RDS. You can decide if your database needs to be publicly accessible or should be accessible only within a virtual private cloud. You get to decide which range or set of IP addresses can actually make connections to your database. So the entire network topology is in your hands. Things like the time zone, how long you want your backups to be retained, whether you want your data to be encrypted or not, and what collation you want SQL Server instance to be running in, again, are all configurations that you can change. If you want, and we recommend doing this for your production and critical workloads, there is a simple checkbox that lets you enable high availability. And when you do that, we set up a database across multiple availability zones. Apart from our monitoring, you might want to monitor the performance of your database. And so we have a slew of tools that you can use, and we'll look at a couple of those today to monitor your databases also. The link below is a video we did last year going even more deeper into all of these configurations and what best practices we recommend that you employ. And this deck is going to be made available for download after this session, so you will have access to the content and also that link. So moving on to our first domain, infrastructure. So AWS is available in 23 regions across 70 availability zones. We have already announced plans for 13 more availability zones across 4 new regions: South Africa, Indonesia, Spain, and Italy. The ones in yellow are the new regions where we now offer RDS SQL Server. In red is Beijing. We did offer SQL Server in Beijing last year, but we didn't have the option of multi-AZ, and now even that is supported in Beijing. At a lower level, from regions and availability zones, we've also added new hardware to our fleet. So as I said, we have 4 instance families. The first 2 are the M instance and the R instance family, and now we support the latest generation of hardware in those instance families. That is the M5 and the R5. The first thing I'd like to point out here is we now have a new variant at the top end. So we have a 24XL variant. The previous generation, M4, R4, maxed out at 16XL. So what that means is when you had a CPU-intensive workload that needed more than 64 vCPUs, you didn't have an option to scale that on RDS, but now with the M5, R5s, the 24XL goes up to 96 vCPUs. The memory also is more on the M5 and R5s when compared to the same instance size on the previous generation. The M5 24XL goes up to 384 gigabytes of memory, and the R5 goes up to 768 gigabytes of memory. These 2 instance families are based on the AWS Nitro platform, and I don't know if you looked at the keynote, but Andrew Jassy also mentioned about that. And because of that, it lets us offer twice the I/O performance than what you would get on your M4 and R4 instances. Moving on to the T instance family, we support the latest generation of the T instance family, which is the T3. Now, the T instance family is really interesting. It is what we recommend for non-production and dev test workloads. The way it works is it has a baseline performance that you're always guaranteed to get. Now, when you're not using your system and the machine is idle, you can accumulate credits that can be used during peak workloads to get performance even higher than the baseline performance. Now, the previous generation, the T2s, you were able to accumulate credits only for CPU, but with the T3s, you can accumulate credits for CPU, network, and I/O. The other thing that we did with the T3s is we have 2 new sizes, the XL and the 2XL, which enables us to offer enterprise and standard edition on the T instance family as well. Now, you might be wondering, why would I use enterprise on my non-production workload? Think of a use case where you're trying to reproduce a problem that you're seeing on your production workload. Instead of spinning up an M5 R5 instance, you can spin up a T3 instance, which is less expensive, and do your testing on that. This is the first time we have introduced a new instance family to the RDS SQL Server, and this is the X instance family. We have the X1 and the X1E, and these instances go up to 4 terabytes of memory. So if you have those in-memory OLTP workloads that Microsoft introduced with SQL Server 2014 Hackathon, this is a great instance type to be running those workloads on. The other thing with this instance type is the ratio of CPU to memory. So on this instance family, the ratio is 32:1, as opposed to 8:1 on the Rs, which was the next best ratio we had. So a use case where you are not CPU bound, but you are memory bound, instead of scaling to a bigger instance size, which has more vCPUs, which also means more licensing cost, you could just switch to the X instance family, get access to more memory, but not have to pay the extra licensing cost. So what does all of this mean in terms of actual performance? So here is a generic OLTP workload that I ran. And as you can see, on both the lower end, the extra large, and the high end, the 16 extra large, I do see an improvement in performance. And this is without me changing anything. No application changes, no database tuning, just simply scaling the instance, which is a matter of a few clicks in RDS. Moving on to storage. So we have two storage types you can choose from. We have GP2, which is general purpose, and we have IO1. IO1 is what we would recommend for your production and critical workloads where you need consistent performance. And as you can see, we have increased the max IOPS and max throughput for both of the storage types. One thing to keep in mind is the max IOPS and throughputs can only be achieved on the newest generation of our instances. So this is another reason why you should upgrade to the M5 R5 instances. Another thing that customers don't realize is apart from just helping you reduce your IO bottlenecks, this also improves native backup performance by around 20%. Moving on to the next domain, security. So SQL Server Audit has been a widely requested feature from our customers, and now it is fully supported in RDS. Auditing tracks and logs events happening on your database to binary files. With that information, you can increase our accountability and prove that you have safeguards in place to make sure that your database complies with any security requirements that you might have. Now, let's take a quick look at the block diagram to understand at a high level how auditing works in RDS. So as you can see, we have the blue color there is the Amazon RDS instance. Now, we have customers connecting to that and doing some activity. Basing on the audit actions or the audit action groups that you've enabled, some of those activities are going to be logged to binary files. When they're on the files, you can read the audit files from within SQL Server. As I said, it's a binary file, so you just can't open it in Notepad and read it. You have to query it from within SQL Server. And since they are on the same RDS instance, you can query it from there. After SQL Server finishes writing to the file, we offload that file to an Amazon S3 bucket of your choice. Amazon S3 is our it's a cost-efficient, highly scalable, durable storage for objects in AWS. It is super easy to upload and download files from S3, and that is where we store the audit files. Once the files are there, you can download them onto the same RDS instance, onto an EC2 instance, onto any SQL Server instance on premises, and query that and look at all the audit events that happened. Now, with that, let's dig a bit deeper into how we use this in RDS. So SQL Server Audit is one of the options that we have. We have 3 options, and this is one of those. The files are stored in an S3 bucket in your account, and we have 2 interesting options. The first is server-side compression. So what we've seen is we can achieve up to 80% compression for audit files. And since audit files are typically not accessed on a daily basis, by compressing it before uploading it to your S3 bucket, we help you save S3 storage costs. And the other option is retention. Why would you want to retain your audit files on disk? Because that is the easiest way to access them. If they were not on disk, you would first have to download them and then access them. So as a best practice, retain your files on disk for 7 days or however long you want quick access to them, and after that, you can delete them from disk and have them on Amazon S3. So with this, let's look at a quick demo on how we can use audit in RDS SQL Server. The first thing, as I mentioned, is we need to create an option group and add the option audit to the option group. So an option group is essentially a logical collection of options. So here, the first thing I'm doing is I'm clicking on the create group button. I'm giving the group a name, some description. Now, options groups are specific to an engine version and edition. So I'm picking SQL Server Enterprise Edition, and the version is 14.00, which is SQL Server 2017. As you can see, I have my group created, the SQL Audit Demo Option group. So I'm clicking on that, and I say Add Option. Now, in the Add Option screen, I have the 3 options that I can pick from, and in this case, I am picking the SQL Server Audit option. The other options are Backup Restore and TDE. Once I do that, now you need to tell RDS in which S3 bucket you want the audit files to be stored. So I'm just picking an existing bucket. It's called Reinvent Demo S3. The next step is to create a role. This IAM role is the mechanism that gives us access to write files to your bucket. Here I'm creating a new role and is giving it a name, and the UI itself is going to create the role for me and give it all the permissions I need to write files to your bucket. Now, the 2 configuration options that we spoke about, compression, and I'm enabling retention for 840 hours, which is 35 days, which is also as long as you can retain the automated backups in RDS. Once I do that, I can either schedule this option to be installed on my instance right away or for a later point of time, and I'm going to just choosing immediately, and I don't want to wait and schedule my installation. So once that is done, within 5 minutes or so, the SQL Server Audit option is going to be enabled on your instance, after which you can log into the instance via SSMS and actually create a SQL Server Audit. We'll look at that also, but before that, there are some rules that you have to keep in mind before you create an audit in RDS. And sorry, I thought I had a question. And we'll look at these rules in the order of the fields on the screenshot. So the first one is the audit name. So the audit names should not start with RDS underscore. That is a reserved namespace for us. We already use it for our FedRAMP and HIPAA audits. The next is the queue delay. So the default is 1 second. I think Microsoft lets you go to like 20 days or something. So whatever is the maximum there, that is what we also allow. The next would be what to do when the audit logging fails. So we do not support shutting down the server, but you can opt between just continuing the action or to fail the operation itself. The next thing we have is the audit destination. That has to be the file. It cannot be the Windows application log or the Windows event log. Leave the file maximum limit and the rollover files to the defaults. The maximum file size, though, has to be between 2 megabytes and 50 megabytes. From our testing, we found that if it's more than 50 megabytes, it becomes difficult for us to keep up with uploading those files to S3. So now that we've looked at the rules, let's actually go and look at a demo where we actually create an audit and retrieve some information from there. So this is SSMS. We all are familiar with this. I have connected to my SQL Server instance in RDS called SQL Server Audit Demo. Now the first thing to do is to create an audit. So under security, I have audits. So I'm going to go right click and say new audit. I am not worrying about the name for now, I'm just leaving whatever SQL Server recommended. The audit log option is to continue. The path, as I said, should be RDSDB data SQL audit. I'm leaving the maximum rollover files and the maximum files to default, and I'm changing the maximum file size to 2 megabytes. I'm just doing 2 because I want more files to get rotated just for the demo. You could go up to 50 megabytes. Once I do that, I OK, and my audit has been created. The next thing to do is to create an audit specification, and this can be at the server level or the database level. I'm just doing the server level here, not worrying about the name. I'm mapping it to the audit I just created, and I'm adding different audit action groups. The first one is the audit change group, so that people, if they disable the audit, that gets logged. The database change group for any alter database commands, the failed login group, and finally the server principal change group for any server principal changes, like changes to my login. Once I have done that, now let me actually go and enable the audit and the audit specification. So right click enable and just close out the pop-up that comes up. Once that's done, we're ready. SQL Server is now ready to start auditing events. So let's do some actions on SQL Server to see how we can retrieve the data again. Here I'm just creating a user if it doesn't exist called the demo user. and I'm granting a system privilege to that user. Now, this is the query that I can use to read the audit events from the files themselves. Again, this query is available in the deck, so you can use it. I run that, and as you can see, at the current timestamp, I have a drop login and a create login just a few seconds because I checked for the user, dropped and created, and excuse me. The next thing we'll do is we'll try to log in as that user, right? But this time we'll give it a wrong password and see how that looks like. So demo user is the user I just created. I'm giving an incorrect password here. Done, login failed as expected. Now I cancel this out and I re-execute the same query. And when that happens, I can see the login failed for the demo user. So this is how you would set up a simple and retrieve information from SQL Server from the files on the RDS instance. There's some more queries I've listed here. These also are in the deck. The first query is to just list the audit files present on disk, and the second query is to see which files are yet to be uploaded to S3. Now, one thing if you'll notice, the file path in the file names, it is RDS DB data SQL audit and transmitted. So essentially, when the audit files first get created, they just get created under SQL audit, and then we copy them to transmitted after we've uploaded them to S3. And that's why in the queries above, I've used a union, and I'm reading for audit files in both the locations. Yeah, these are the queries I mentioned. The next thing for security is the SQL agent operator role. So SQL Server agent is supported in RDS, and there are 3 roles that primarily apply to SQL Server agent. There is the reader role, there's the reader role, the user role, and the operator role. The reader role, as the name says, lets you read the properties of all the jobs on the box. The user role is also supported in RDS, and that lets you create, stop, start, disable, enable, and delete a job that you have created. Now, for many customers, this is sufficient. However, there might be a use case where user A needs to modify jobs that user B set up. For example, say DBA Bob made some changes to the daily ETL job, and he disabled the job, made some changes, and he went on vacation. He forgot to enable the job. Now DBA John comes in, and he is unable to enable the job anymore because he has the user role that doesn't let him do that. So one workaround for this is to share a common DBA account. That way, DBA Bob, DBA John have the same account, and they just use that. The problem with that is security. It's never a good practice to have a common shared DBA account. So to address that, what we did is we now support the SQL agent operator role in RDS, so you don't have to share a common DBA account. The problem in RDS, however, is SQL Server assumes that if you are part of the agent operator role, you also have access to an extended stored procedure called xp-reg-read. And in RDS, we revoke access to that. So if you log in as a login that is part of the role, that is the error message that you will see. So because of this, we couldn't just add all the master users to that role. Instead, what we have done is we have given you access to add yourself to the role. So instead of adding yourself to the role and then logging in and seeing the error message, you log in and then you add yourself to the role, so you have access to change other users' jobs, but you don't get this error message. And this is a bit tricky to understand in a setting like this. So we actually have a detailed blog with screenshots that explains this much better, and that's also linked here. Moving on to the next domain, monitoring. So the block diagram there might look overwhelming. It really is not. It's pretty straightforward, and we'll go through that. The first thing I'd like to mention before we get into the block diagram is that we now support integration with Amazon CloudWatch logs. So CloudWatch logs is a highly scalable service that enables you to centralize logs from different systems, and now including RDS SQL Server, to one common place. Once they are there, it's easy to search for patterns and create filters on that. So now let's look at the block diagram. So I have users connected to my RDS instance doing some activity. all of those events which are logged in either the error log or the agent log can now be streamed to CloudWatch. So if I go to CloudWatch UI and I see, what I'll find is a sequence of timestamps and messages from the error log or the agent log. Now, once I have the information in CloudWatch logs, I can easily create a filter looking for a certain pattern like login fail or deadlock detected or transaction log filled up, and just certain phrases like that. We can search for those and we can create a filter on top of that. And once the filter is created, we can create an alarm and we can send a notification to ourselves via SNS saying that something unexpected is happening on the instance. And I do have a demo for this, so that will make it a little easier to understand. The other thing that you can do from CloudWatch is you can export your error logs and agent logs to S3 for archival. You can also stream CloudWatch log events to AWS Lambda. You filter on some phrases and you stream that to Lambda. And once in Lambda, it's essentially serverless code, right? So you can consume these events and do whatever you want with that. And we also can stream to Amazon Elasticsearch Service, which is our managed Memcached and Redis. So before we get to the actual demo, it's good to understand the different components of CloudWatch logs. So think of it as a folder hierarchy. Okay, so the one in yellow is my instance name, so that is my top level folder. The ones in red can be considered my second level of folders, and those are my log groups. And below my log groups is my third level of folders called log streams. So in RDS, as I mentioned, we support streaming messages from the agent log and the error log, and that is the first two log groups you see there. And if you can see this, but yeah, that's agent and that's the error. Under those two log groups, you have the node 1 and node 2, because this was a multi-AZ instance, and I have the primary and secondary, node 1 and node 2. The third log group you see here, and the log stream that belongs to that, is only applicable to multi-AZ instance, and what that does is it keeps track of which node was primary at what point of time. So you can use this along with the individual node log streams above to track and understand what was happening on your primary and what was happening on your secondary. A few more things to keep in mind for CloudWatch log. All the timestamps you see in the UI are all UTC. So if you are running your database in a different time zone, make sure to remember to translate that before you start correlating events. The upload times are really quick. I've seen uploads happen as quickly as 20 seconds. And when you do a snapshot restore or a point-in-time restore of an RDS instance, on the restored instance, the integration with CloudWatch logs is disabled. So if you want that integration, you have to re-enable it on the restored instance. So with this, let's look at the demo for CloudWatch. Now the first thing is, how do I enable integration from RDS to CloudWatch logs? It's really straightforward. I'm just picking my instance here, clicking on modify. Once the modify screen loads up, I'm just going to scroll down to the log exports section. And as I mentioned, we have the two log types we support, the agent log and the error log. I'm choosing both of those and I hit continue. Unlike other modifications in RDS that can be scheduled, exporting to CloudWatch logs happens immediately by default. Once that is done, it's going to take some time for the log groups to get created, but I already have that for a different instance that we can look at. So this instance is just reinvent CWL demo, that is the instance name. And so my log group format is AWS RDS instance, the instance name, and the log file group. In this case, it's the agent and the error. Opening the error log group, I have just one node because this is a single AZ instance. So I open that log stream, and in that log stream, what I see here is what I would expect to see from a SQL Server error log. So I have the timestamps, and I have the events, I have some login failures, I have IO being frozen when I was doing some snapshots. If I scroll up, I have some dbcc check db commands when I was doing some database consistency checks. So essentially what I would see on my SQL Server instance, I can now see in the AWS console. Once that's done, now let's start looking at the different integrations that we can do. The first one is like really straightforward. It is exporting this to S3. So just choose my log group, actions, export to S3. I just give it a from and a to timestamp, and I tell it which bucket to export to and export data. That's it. So all the events during that time frame are now being streamed to Amazon S3. The next thing is we'll see how we can create a metric filter on what I have in CloudWatch. So I'm just going to choose my log group, the error log group. I'm saying create metric filter. The pattern I'm looking for is login failed. So I just type that in there and I say assign metric, and I'm giving my metric a name. So once the metric has been created, I can now create an alarm on top of my metric. So I just click on the create alarm link, and as you can see, it says period 5 minutes. So within a 5-minute period, if I have more than 10 failed logins that I just typed in there, I want to be alarmed. If data is missing, just going to as missing, and just hit next. So when in alarm, I wanted to send me a notification to my email. So I just configured my notification there. Once that's done, hit next, and now I'm giving my alarm a name. So we had a metric name, alarm name, just reviewing that everything looks good. I have my threshold set to 10, notification to myself, and I say create alarm. Okay. So right now it says insufficient data, but after a while that will go to OK status, and if I do have failed logins, it will go to alarm and I'll get a notification. So let's go to CloudWatch Insights and see how I can query my logs to graph out some of this stuff. So I'm taking a very simple exception, and I'm again going to search for the word or for the words login failed. I just type that in there, and I am picking a 6-hour window, and I need to tell CloudWatch which log group to run that against, and I'm picking the error log group. So once I've done that, I just hit run query. It takes a second for the query to run, but then I have a histogram of my login failures. I can now select the specific time frame that I saw some login failures to get an even more granular view. And once I see that, I have more information, and I can correlate this with what I was seeing in my login failures in my actual error logs. The next thing we will look at is integration with Lambda. So as I said, I already have an alarm for when logins fail, but what if I want to get more information? Right? That is when I would start streaming to Lambda, and we'll see how that looks like. So the first thing I'm going to do is choose the log group, go to actions and say stream to AWS Lambda. You already have a Lambda function created, and we'll take a look at that. I select my Lambda function. Next, the log format, I'm again going to search for login failed. So login failed, only the events that have login failed are going to be streamed to Lambda. And then I just say start streaming. So once this is done, the events will get to Lambda, and Lambda can process them. Now let's actually go and take a look at what the Lambda function looks like. And I'll also show you the difference in the two notifications I get from just the CloudWatch alarm and from the Lambda function. So this is the function I have, report failed login. It's a very, very simple function. It is triggered by CloudWatch logs, and it uses SNS to send me a notification. The code for the Lambda function is also in the presentation, so you can play around with that after the session is done. Now going back to our block diagram, and so this is how a notification would look like from the alarm I created. Right? It tells me that this alarm went to an alarm state. It shows me my thresholds and the time it happened. If I click on the link, I can go to the actual alarm and look into how it was configured, which instance and all that stuff. But what if I wanted more information? That is where I leverage AWS Lambda, and this is how that would look like. So not only do I get a notification saying that some logins failed, it tells me which logins failed, why they failed, and from where they were trying to connect. So if you have any stored procedures in RDS, you can always raise error to the error log, and you can base your monitoring and your alarms basing off of those errors also. This is the sample Lambda function that I was talking about. So moving on to the next thing for monitoring is performance insights. So those of you who are familiar with other RDS engines might have already used performance insights. We now support it on SQL Server as well. So performance insights essentially is an easy to understand performance dashboard with system level and session level information. It is enabled by default on all RDS instances, and for up to 2 weeks it is stored without any additional cost. If you want to retain the data for more than 2 weeks, you can configure a retention for that and it goes up to 2 years, but there is a nominal cost associated with that. It also gives you database load information, and you can look at which SQLs were your top SQLs, and in the top SQL, what were the wait events that it was waiting on. And what we'll do is we'll do a demo to see how we were able to use performance to dive into a pretty interesting performance problem that we saw. And along with the SQL information, it also gives you the SQL ID. If you append 0x to the SQL ID, that is the SQL handle, which you can then use in SSMS to get a lot more information about the query. So before I start the demo, just a quick setup. So essentially what we did was we took a SQL Server 2012 instance, we did a snapshot restore, and we upgraded the restored instance to SQL Server 2017. Both of them have the same hardware configuration, and we ran the same workload on both instances. And let's see what we actually saw. So the two instances that I'm interested here are the reInvent demo PI 2012 and 2017. 2012 runs SQL Server 2012, 2017 runs SQL Server 2017. The first thing I see is there's a lot more CPU being consumed on my 2017 instance, and it also has a higher number of average active sessions. And I know for a fact that the workload on both of these is the same. Now let's actually go into the Performance Insights dashboard and see how we can dive into this problem and root cause this. The first thing is, how are you going to get to the PI dashboard? So you go to your RDS homepage, click on the 3 lines there, go to Performance Insights, and you can see a list of all the instances on which I have PI enabled. I have already opened the 2 instances into different tabs. This is 2012 and this is 2017. So going back to 2012, the first thing I'm going to do is I'm going to add some system level metrics under the counter metrics section. To get a good idea of the total work that the instance is doing, I'm choosing batch requests, and to see, since I'm seeing CPU variations, I've also picked latch weights. Now I can see the 2 metrics there. I'm doing the same thing on the 2017 instance. I'm picking latch weights and batch requests. I picked them in the reverse order, so the graphs came up reversed, but I'll again call that out. And now I have counter metrics for that also. Going back to 2012, if I look at the latch weights, that's the first graph. I'm averaging around 36, 37, and my batch requests per second is around 427. If I go to my 2017 instance, my graphs are flipped. So the first one is batch requests per second. It's 353, around a 25 to 30% drop in performance, and I'm seeing a lot of latch weights. Right? So now that I have this high-level view that yes, my 2017 instance is doing less work, let's actually dig into the database load and see what happens. One call out to that small checkbox there called vCPU. So if that is unchecked, you get a wide graph. If that is checked, what we do is we show you the relative performance with respect to the number of CPUs you have. So on 2012, when I click that, I see that my graph compresses because there are not that many active average sessions. In 2017, however, the graph doesn't really get compressed so much. So I'm going to go back to my 2012 instance, and I'm going to uncheck this such that way I have a wider graph to look at the wait events. So this is 2012, I've unchecked it. Now I'm going to start looking into the different wait events I'm seeing. The first one seems to be the gray color, which is write log. So it's a write heavy workload. I'm writing to my transaction log, and SQL is waiting on that. I see the blue and yellow, which is just locking, and green, which is CPU. Which is kind of what I'd expect on the normal SQL Server instance. No application can be written without any kind of locking, and that's what I'm seeing here. On the 2017 instance, I look at the same thing. So here, the yellow is write log. So the first wait event is kind of the same, but it's a lot more write logs. The blue here, if you can see, is CX packet. So this is a wait event that I did not see at all on my 2012 instance. So that seems to be interesting, and now that I think about it, when I see CX packet wait events, I am bound to see CPU utilization spike up. I can also slice my database load per SQL, and so now I have my top SQLs here. I'm going to go back to my weights, and I'm going to zero in on that one weight itself. So I click on that, and as I can see, it's only one SQL that is contributing to that wait event. Now, once I have identified the problematic statement, I can click on the drop down there, and I can see the SQL text and also the SQL ID. So once I have the SQL ID, just append 0x, I can go to SQL Server Management Studio and get the actual execution plans. And I did do that, and this is what we saw. So in 2012, it was doing a nested loop over 2 index seeks. In 2017, it was doing a full table scan, and to process all that data, SQL Server was using parallelism, and I'm guessing that all the CX packet and the CPU spikes was the intercommunication between all the parallel slaves. So once we have come to this point, now it's a matter of tuning this one SQL, right? So the things I could do is I could change the database compatibility mode, I could change the SQL compatibility mode for that one SQL, I could maybe create an index in 2017, or I could go back and check my statistics and see why is it that 2017 is picking a different plan. Right? So, but the main idea there was to give you an idea on how we can drill down into a performance problem using the tools in Performance Insights. Moving on to migration. So now RDS supports database restores of up to 16 terabytes. So previous to this, our maximum was 5 terabytes, and that limit was governed by S3's maximum file size. So you can't upload a file greater than 5 terabytes to S3. But now what we did is we support restoring from multiple backup files. So say you had a 15 terabyte database, you could back that up into 5 files of 3 terabytes each, and you could restore from all the 5 files onto RDS. We support up to 10 files per backup, and because of this, we were able to lift the restriction of 5 terabytes, and we support up to 16 terabytes being restored onto an RDS instance. The other thing we did to make migrations better is we now support differential and log restores. Now, why is this good? Because with this, you can actually migrate a database from EC2 or on-premises to RDS with a downtime of as less as 5 minutes. And we actually did this, and in a minute I'll show you the timeline of that migration, but I do want to quickly just go over the block diagram. So for a normal migration, the gray is your on-premises SQL Server instances. You can just do database to disk, and all the backups can then be uploaded to Amazon S3. Once in S3, you just connect to the RDS instance, you call a store procedure, and we restore that from S3 onto the instance. Now, we have taken that same thing, and now we have new procedures to also do a differential restore and a log restore. So this is the timeline I was talking to you about. So as you can see, I migrated a database from on-premises to RDS starting at 8:25, and I finished at 9:55. However, let's look at it step by step and see what my actual application downtime was. Now, the 3 streams you see here are backups, and then uploads, and then restores, and that's how all of these would go sequentially. You would first backup on premises, you would upload the backup to S3, and you would restore onto RDS. So the first thing I did was a full backup, and then I uploaded the full backup to S3, and then I did the full restore. Now, if you notice, the full backup is a really short window because I really wanted to prioritize how fast my backups were, so I used a big max transfer size, and I used 64 buffer count. I also took the backup onto locally attached SSDs, which is like super fast. Those disks were not durable, but for a backup, I didn't really care. Once my full restore was almost finishing, so the full restore finished at 9:40. Like 5 minutes before that, at 9:35, I took a differential backup of my database on premises, and then I uploaded that to S3, and then I restored that onto RDS. I did the same process for log 1 backup, log 1 upload, log 1 restore. After that, I shut down my application. So around 9:52, 9:53 is when I shut down my application, and I did my final log backup. The final log backup, upload, and restore all finished around 9:56, 9:57, and at that point, I could just reconfigure my application to point to my RDS instance and start my application. And with that, I was able to migrate my database from on-prem or EC2 to RDS with a 5-minute downtime. This was a 500 GB database, but it actually doesn't matter on how big the database is, because you can keep the process going on till your log backups become very, very small. The other thing you can use the same process is to set up an ongoing disaster recovery database in RDS. So you start off with the full, the differential, and then you keep doing the log, backup, upload, restore cycle. And when and if you need to fail over to RDS, you just go and we have a last store procedure, which I'll show you in a bit, to complete the restore. And when you do that, the database comes online and is accessible on RDS. So these are the store procedures that I used for this migration. Everything in white always worked in RDS. It was there even last year. Everything in red is new. So as you can see, starting with the type is equal to differential, that is new. And towards the very bottom, when I said that is the finished restore DB for your disaster recovery situations. For migrations, the other thing we did is we started to support a bunch of new versions that have fixes specifically for CDC. I have the Microsoft links there that point you to the actual bugs that Microsoft worked on. Like the first one is pretty interesting. Microsoft in the code, they actually forgot to add a /60 to the end. And so we worked with them and then they realized and then they changed that. And so in all of those versions of SQL Server and in the parentheses I have the RDS versions also listed, that issue is fixed. In SQL Server 2017, we had another problem where it just wouldn't work and we worked with them and they've resolved even that. And so if you're using CDC on premises or on EC2 or in RDS, make sure that you're on one of those versions to have a seamless migration process. So that was the last domain. We also have 3 new features that I wanted to talk about today. And the first is server level collation. So collations in SQL Server are used to define rules around sorting, case and access sensitivity properties of your data. Database level collation was always supported in RDS. You could change the collation of your database. The server level collation was not, and that is what we've announced this year. Now, why is it that you care about being able to change the server level collation? So say you are doing a lot of activity in TempDB. You run your daily ETL job, you create a bunch of temporal tables in TempDB. Now, if the collation of that doesn't match the collation of your databases, that is going to mess up your results. Right? Just for temporal tables itself, your sorting is going to get messed up. If you are doing a big join on 2 tables in your own database, but the join is, say, it's a hash join and SQL Server didn't have enough memory granted to that, it's going to spill over to TempDB, and TempDB, being a system database, is going to use the system server level collation, which is not what you want it to be. That is why we now support changing the collation at the server level. Few things to keep in mind. This can be configured only when you create the instance. Okay, this is non-modifiable after that. So about how you're going to use your database and choose the appropriate collation. Even if you do a snapshot restore of this instance or a point-in-time restore of this instance, it is still going to retain the same collation. Now, we support 19 collations in RDS, and we're looking to add more. If you're doing any of this from the CLI, we don't have a switch that says -- collation. We just overloaded the character set name switch because other engines had support for this previously, and it's called character set in those engines. The other thing we did this year was we increased the number of databases that you could have on an instance. So prior to this, 30 was a blanket cap across all our instances and our instance families, and now we have gone to a more variable model. Why is this important? This helps you consolidate your instances. It helps you save licensing cost. For example, say that you had 100 databases that you wanted to store on an instance. Before we made these changes, you had to provision at least 4 M5.large boxes, right? Most of those databases might be extremely inactive. They don't need any CPU. Some third-party application just configured it as a different database, and so it's there, but that doesn't actually impact your CPU, so you actually do want to consolidate. Now, you can, instead of going to 4 M5.large, you can go to one single M5.extra large. So an M5.large has 2 vCPU, So you were consuming 8 vCPUs and paying for 8 licenses before, and now if you go to the M5.extra large, it's one box with 4 vCPUs, and so you've halved your licensing cost. So if you are already using databases on RDS, do look at how your database distribution is and see if you can consolidate them and save some licensing cost by leveraging these higher limits. Now, do keep in mind that the number of databases you have is dependent on the instance size and the availability mode. As you can see, the bigger the instance size you go to, the more databases you can have, and the moment you enable multi-AZ, the limits do drop. And if you see database mirroring, which is Microsoft's older HA technology, is pretty CPU intensive and consumes a lot of CPU threads, and that is why we can't offer the same number of databases that we can on always on, which is the newer HA technology for Microsoft. Now you might have a question as to how do I know if I'm using mirroring or always on in RDS? It's just a checkbox that says enable multi-AZ. So that is visible in the console. So for your instances that have multi-AZ, there is also in parentheses the mode that is being used. So it says either mirroring or always on. But for easier, just keeping this in mind, if you're using Enterprise Edition, the latest version of 2016 and 2017 will come with always on. The other important aspect with this is this also is going to have implications to your ability to scale up or scale down. So say you had an M5 2 extra large and you had 100 databases, you could scale that down to an M5.extra large, but you can't scale that down further to an M5.large because that can only go up to 30 databases. The same thing, you take your M5.2 extra large, which had 100 databases, and you now try to convert that to multi-AZ. That is not going to work because with multi-AZ, you have a limit of either 50 or 75 depending on mirroring or always on. So keep all of this in mind when deciding how you want to distribute your databases across your instances. But the main thing for us is we have increased the limit, so this should help you save costs and consolidate. The last feature that I wanted to talk about today is our integration with S3. Now, this might be a bit confusing because we already spoke about offloading audit files to S3, we spoke about doing restores from S3, and then we're again talking about S3 integration. So this is different. So this, just think of this as a platform that we have built to upload and download different file types from Amazon S3 to the RDS instance. One use case for this would be, say you wanted to use bulk insert, right? So you have your data files, which are like maybe CSV files or text files, and now you want to bulk insert from that into a SQL Server table. With this feature, what you can do is you can upload the file to S3 and download that from S3 to the RDS instance, and then you can bulk insert that in. The other use case for this is audit files. So before we launched this feature, even though we supported SQL Server Audit, we would tell customers to download audit files to an on-premises or an EC2 SQL Server instance to query the files, right, after the retention period is done. But with this, you can download those files onto the same RDS instance and read them right there. For me, this is, the two use cases here are just the starting, right? This is essentially a platform that we intend to use for a lot of other features that will come in RDS pretty soon. Now, how is it that you can enable S3 integration with RDS? So unlike other options which were done via option groups, this is done via instance level roles. It's extremely straightforward. If you go to your RDS page, you go to the network and configuration tab, and there you have this section that says managed IAM roles. You create an IAM role based on our documentation, and then you just use that role and you select the S3 integration feature. That's it. Once you do that, you now have access to these new stored procedures I've listed here, and the names are pretty straightforward. We have one for download, upload, to list the file details and things like that, and we also have one to delete a file from the file system. So just keep that in mind. You download a file, you bulk insert it, you might forget to delete that file, but that file is consuming space on your storage, so use that procedure to delete the file. And if you want to create files, if you want to create folders on the RDS instance, because by default we store all the files we download into DS3, but say you wanted to go into like DS3, like bulk insert in the download procedure itself, when you give us the file name, just give us the folder path and we'll create that and put the file in the folder that you created. So that brings us to the end of the presentation. We've been telling all our customers this. So you are here at reInvent to learn, and learning doesn't have to stop just because reInvent is done. There is a lot of material available for training and certification online. AWS.training is our portal. Today we just spoke about SQL Server, which is one of the 6 engines in RDS, and RDS itself is one of the database services out of 7 in AWS. As you can see, for different use cases, you might want to use different databases, different data persistence layers. We have a 4-hour course that specifically talks about the different use cases that you might have and which database technology you might want to use. Once you're familiar with that, you can then attend more training for individual services. Like for RDS, we have courses for every engine that explain how we can do whatever we spoke about today, and plus even for like very, very beginning, how do you create an instance and from that level. So with that, I thank you for your time today. This deck is available for download, and this presentation is going to be on YouTube, so you can always share it with anybody else who might be interested. And we have 3 more minutes, and I can take any questions that you might have. Oh, sorry, go ahead. Okay, so the question was, will we have read replica for SQL Server? So we really can't share things on our roadmap in a public forum. So what I would say is reach out to your account manager and have him reach out to the SQL Server product manager, and that is the best way for you to understand what's coming on the roadmap and when. So for right now, I'll say that if you can use database migration service, which is a logical replication tool, you can use that to spin up a replica that is readable and writable, and you can configure permissions to make it only readable. But that is one way of doing it today. But for more information, do reach out to your account manager and get them to talk to the product manager.
Talking about DMS, right?
Yes.
The only choice we have to enable CDC, CDC also has its own weight on production server.
Right. So the question was, were we talking about DMS? Yes. And then the thing is, for DMS to work, we need to use CDC, and that itself is going to add extra logging to the transaction. That is true. The only thing I'll say about that is CDC and MS replication are Microsoft's native technologies, and yes, they do add some extra on the system, but I wouldn't say it is catastrophic. Definitely, if you're doing a lot of writes across multiple tables and all the tables have CDC enabled, you will see a performance hit, but that is when we have to think about instance scaling or sharding the instance and things like that. Yeah, sure, go ahead. Okay, so the question was, you have multiple databases on one instance and somebody dropped one table in that database, how do you get it back? So right now the best way to do that would be to do a point-in-time restore of the entire instance to a new instance, and once that is done, you have your table on that database there. If it's a small table, you can just export that and import that here. If it's a big table, then you can export that, you can back up the entire database to S3, drop it on this, and then restore it here.
So I can restore snapshot into a different name?
Yes. Yes, so the question was, can I restore a snapshot into a different name? Yes, that's how all snapshots work. You can give it a name when you restore it. Okay, so we're out of time, but I will be available here in case you want to chat. Thank you for your time today.